Hello, I'm Angie Dowdell. I am a natural language data scientist. I mainly specialize in language and linguistics and how computers talk to humans and humans talk to computers. And even before ChatGPT became a thing, I was working in that field for about 5 to 6 years at that point. And I started out working in the military or for the military for a psychologist, Dr. Randy Brew, who was working on the objective interpersonal assessments of emotions and skill sets of empathy between leaders and subordinates. And I developed a chat bot for him that had emotions and contextual appropriateness and generating responses that seemed witty and human-like. And from there, I became very passionate about chatbots and technology design and HCI components of journey analytics, conversational marketing, and the like. It's very broad. Even now, I specialize in creating avatars that are interactable and used as agents in the classrooms for clinicians and autism specialists and neurodivergent sectors as well. So it's a broad skill set, even though I started out in military/banking and investment brokerages. I also have ventured out into the medical spaces of training, helping clinicians automate some of their work with training their employees and their specialists, and without having to repeat themselves all the time. The uses of AI go on and on. Their generative uses, classification uses, as well as some may say of categorization uses, summarization uses. Also multimodal with audio, visual. Police officers may use AI to detect biases, threats, and needs for training amongst their officers by putting body cameras on their employees and giving them objective feedback at a later date using Gen AI as well. We rely on large amounts of data for you could say big data modeling, and now we call that specifically large language modeling. And we also rely on not reinventing the wheel, but checkpoints and pre-distilled, or you can say pre-trained models that have the nuts and bolts of what we're looking for in functionality and just need to be customized for a specific cohort of customers or a special use case or a company or a team. And that's where I come in. I'm the person who you call when you need help with learning how to use AI, and a developer and architect who can actually implement it as well. So I love teaching, and I've been teaching as well for about 11 or 12 years now as a paraprofessional in the classroom. I've also ventured out into teaching STEAM, science, technology, engineering, arts, and mathematics. I say that because I'm also a creative, along with being someone who has always loved math. I'm a creative, and I love making music and artwork. Always have been a designer, but from the time I was born, I've been designing since then, and I love to integrate that with technology. There is a huge design component in NLP and natural language. And sometimes, because I am so artistic, people have gotten confused about the developer engineering side of me as well, which is still there, and a burning desire to infuse the two together in a more mainstream fashion, where people see it as normal to have both because you need both. With that being said, I want to come here today to speak to you about child education between the ages of kindergarten or the levels of kindergarten to K4 specifically. Now here in Atlanta, Georgia, where I live, sometimes fifth grade is clustered in with middle school, unfortunately. And I say that because personally I enjoyed having that fifth grade, my last fifth grade year in elementary school. But that's what is more common today. And so I'm going to focus more on K through 4 for the sake of this conversation, although I've worked with college students even up to the age of 60 and beyond. I I work with a broad array of age groups, even toddlers and kindergartners, up to kindergartners as well. But today I want to focus again on K through 4. When we teach our children computer science, there are some things that we have to keep in mind. Every child has different interests, and we want to make sure that we probe those interests before we just start giving them projects. So some children are interested in trades and common everyday things that, like, for example, I'm trying to remember the name of that specific field in diesel engineering, where you inspect the tanks of certain engines to make sure that they meet the certain baseline measurements and they're safe for use. Some people may want to become welders or plumbers, or they may want to become hardware technicians for electricity and a cloud computing facility. They may want to become a nail tech, or in the future, a beautician, a cosmetologist. And if you're teaching a child from the mindset of, when I grow up, I want to be an everyday blue-collar worker, if you're teaching that child, you may have to approach it differently, because they may not see mathematics or computer science as relevant to their learning. And I've heard students say that before, especially college students. They will comment and say, I don't think this is relevant to me. I don't want to do this. So that's at the beginning. You have to level set and tailor make your curricula to fit that student's interest. Because like many fields, computer science is broad and vast, and it touches every single industry. There's no such thing as leaving computer science. Everyone has a place in computer science. And in today's digitalized world, it's not just about AI or machine learning, but in general, we want to teach all of our students, whether they're in the medical field or whether they want to be a nurse when they grow up, shall I say, want to be a teacher when they grow up, want to be a stay-at-home mom when they grow up. Whatever they want to be, let's show them something that they can do with AI, with machine learning, with computer science that is fun for them specifically. Now, beyond that, here are some things that I want to quote from I will name the authors. I believe the authors are Dr. Caldwell, Perman, Krotowski, and Quigley. These are some of the authors who contributed to a curricula that I really enjoy using for teaching children computer science. So they go from the broad topic of computer science. What is computer science? What is a computer? How do we define a computer? To hardware specifically. Some people are more of hardware folks, they may say, than software. Others are a combination thereof. So we want to introduce children very early on to a tangible form of computing that they can touch, that they can fix with their hands, like robotics, for example. There may be an interest in wearable computing or tactile computing, which kind of combines hardware with software. And gaming, they may be more interested in gaming. That's a huge thing. A lot of children, if you ask them what do they want to be when they grow up, depending on the neighborhood you're in, they're going to say football, basketball, and not music so much nowadays, believe it or not. They may say that they want to become a fashion designer, things of that nature. And most importantly, all the kids mention gaming. I love playing games. I love playing games. I love playing games. Or you may have the occasional artist. These are things that you want to kind of integrate into your curricula as well. Computational thinking, that's decomposition, abstraction, patterns, algorithms. These things are super important when teaching children how to problem solve. This is important in general, even outside of just computer science. We want to train our children to not only be retrieval-based thinkers, where they memorize facts and retrieve them out of some part of their brain where appropriate, but rather that they start to make activated neural connections that go deeper, and that they can come up with a vast array of topics on their own, start to synthesize that information in a critical thinking fashion. So in computing, we call that decomposition, breaking a problem down into its most smallest unit and attacking it from that simplest, smallest unit, which is so important for software developers. Abstraction, which is kind of like pattern recognition, patterns, and algorithms. So these are some of the things that algorithms, of course, my teacher from computer science always said it's kind of like, how do you make a peanut butter sandwich? Breaking things down one step at a time. Nowadays, we see that prompt engineering is popular, and it doesn't require as granular of details for computing that we saw in traditional AI or lower level programming languages. However, it's still important to start teaching children to think about algorithms early on. Another thing that's important is to start to teach them what data looks like on a basic unit level. In chemistry, we think about the atom and the electrons and the protons and then the nucleus of the atom. In the similar fashion, we need to think about the basic unit of data. What does that look like? Bits, digitization, binary code, ASCII and Unicode, logic, gates, databases, and encoding multimodal data, images, audio, video, and encryption on the security side of things. We also want to cover things like programming techniques, pseudocode. What does pseudocode look like? How do we map out the flow of our logic on paper before we program? Some children who are neurodivergent hate that step and don't need it because they're so brilliant. They won't need that. Early programming methods that, from the early days of programming, analog programming, Boolean logic, 0 and 1 thinking, and translations. What is a compiler? What is an interpreter? What is an assembler? And how do we interpret software errors? Programming languages. What do programming languages do? What type of computer programming languages are there in existence? What is an application programming interface? An IDE. And some of the popular languages like C, C++, Java, Python, Ruby, JavaScript, Scratch, Odoo, and future languages. And we want to get into talking about cloud computing as well. Unfortunately, in the curricula that I have been referencing here, they don't include cloud computing. However, I will probably put cloud computing at the top of the list after we get past the basics of computing, such as data, programming techniques, computational thinking, hardware, and networking. Okay, so never mind. They actually do include the cloud computing underneath networking. And so this gets into some aspects of cybersecurity as well, because as you know, cloud computing has a vast, deep, and aspect of cybersecurity nowadays. And we also want to include things like website, app construction, developing and designing apps, and testing and maintenance. Of course, nowadays, we want to show children how to create apps both from scratch and with tools like Replit, Streamlit.io, and we want to show them how to use Gen AI to create websites, but we don't always want to go there first. We want to show them where it all started and how to be real web developers for those who are interested. Digital behaviors. So what is safe use of computing? Computing is a privilege. We want to teach, just like driving, for example, we want to teach children how to use computers safely, and ethics associated with computing in the classroom, online and digital identities. So nowadays, having an online avatar is very popular. So kind of counseling students through their online identity versus who they are as a real person is important for both adults and children. Maintaining balance as a digital citizen and staying safe online, cyberbullying, hacking, and privacy. These are things that we want to cover. Social media, another privilege, a huge thing to teach children about are the ethics of social media and what is social media, how did it all get started, the safest ways to use social media. For example, there is a author named Cal Newton who actually suggests that we don't even use social media on our cell phones because of the impact on our cognition as people and the impact to our productivity. Personally, I don't have Instagram or apps as such on my cell phone downloaded and installed there because it's just a distraction for me. But for children, I'm starting to teach them the proper use of cell phones and social media for their safety is a huge aspect of teaching computing K through 4. Digital issues, so digital literacy, we want to teach them the numbers behind that based on population, nationality, location, and then also teach them where they should fall in the digital literacy curve. We want to teach them about accessibility and computer science. I think a company that obviously does a great job with accessibility focus of HCI design is Apple Computer. Apple, the computing company. They do a great job with thinking about those who are visually impaired, who may be impaired with their hearing or even with their cognition or with their ligaments, etc. I think they do a fantastic job with creating like a metaphorical user interface design that helps everyone despite their ability or disability. And that's something to teach children about, is how to have inclusive thinking in computing. Now, the future of computing, that we can only extrapolate on. It's kind of emerging now with things like Meta AI and kind of like the holographic experience of the, you can say, augmented reality, virtual reality world. And we want to get into teaching them about cryptocurrency, although many financial experts are not a fan of crypto. Just giving children basic introduction to this is important. And biological interfaces for those who want to become biomedical engineers in the future, which some are that aware. We do want to show them little glimpses of what AI can do and computing. Artificial intelligence in general and thinking, I like how they put it here, thinking outside the chip. And I think that's a pretty cumulative overview of what we want to cover in our approach to teaching children about computing. We want to teach them about some of the notable figures such as Ada Lovelace. She's super popular. There's a conference about her every year. One of the first computing programmers who also was a woman, and that's pretty huge. And we want to teach them about also some of the underrepresented individuals who participated in creating the world we know today with digital computing, who never were mentioned in the history books. That's super important as well. And don't let me forget medical field. In the medical field, there's a software called Genesis, and that's only one example of the plethora of ways that technology is used in the medical field. Of course, there are a plethora of patents and innovations that have been used for diagnoses diagnostic tests and exams. And those are some cool things to mention to children, to have them think about computing in general outside of the idea of just a computer programmer. And that whether they are designers or future entrepreneurs who are going to have to use social media and design tools, or someone who's thinking in the corporate America context, there are going to be a plethora of ways they're going to interact with computers in their everyday life and possibly in their futures. And I think giving children a robust opportunity to learn will close the opportunity gaps and mitigate some aspects of the barriers that they may face in the future if they do come from an underrepresented population in computing. If they don't, it still will help them as well. I just wanted to give this as my take on how I approach data science and computing in the classroom for K-4 and beyond. Let me know what you think. And my name is Angie Dowdell. You can email me at angie@sololatango.io to learn more about how to teach your child computing early on, teach your students computing early on, or how to teach yourself computing early on. It has been a privilege coming before you today, and I appreciate you joining us. This is Solola Tango. Here at Solola Tango, we focus on the seamless and rhythmic interaction between humans and machines, which is becoming more and more of a thing every day. I appreciate you for being open-minded to thinking about the human aspects of computing.